Hi everyone, and welcome to the Mat 211 review of conditional probability and independence. My name is Julia, and I work for the tutoring centers at ASU. So, for today's problem, we have a weighted coin that we're flipping twice. The coin has a 51% chance of heads and a 49% chance of tails. We want to use a probability tree to determine the probability of flipping tails first and heads second. And we're assuming that these events are independent. So the first thing we want to do is we want to draw out our probability tree. So we'll start at this first node here and we'll draw a line here and here. And so this represents the first flip. So first flip. And we can have either heads or we can have tails. Now, if we have heads, there's a 0.51 probability of getting heads. And if we get tails, that comes with a 0.49 probability. So now we're going to split these again. So we have another heads here and a tails here. That's for our second round. So we'll say second toss here. And we also have a heads and a tails here. So if we get heads the first time, it doesn't matter whether we get heads the first time, what happens in the second. It's exactly the same. So if we get heads in the first round, our probability of getting heads again, because these events are independent, is again going to be 0.51. Likewise, if we get heads on the first toss and we get tails on the second toss, again, these two events are independent, so this will be 0.49. And the same is true if we get tails on the first toss. Our events are independent, so our probabilities are going to be the same for heads or tails. So now that we have our tree written out and our probabilities filled in for our tree, we want to think about how to use this. So notice we're looking for tails first and heads second. So that means we're going to go down this branch for the first toss, and then we're going to go up this branch for the second toss. So since these are independent events in sequence, and that is important here, these are independent tosses, we can just multiply the two probabilities for the path that we take in order to get the probability of both events happening in sequence. So that means that if we have the probability of tails, then heads, that's going to equal, well, our probability of tails for the first toss, which is 0.49, times the probability of heads for our second toss, which is 0.51. We can go ahead and multiply this out, and that gives us 0.2499 for our probability, or 24.99%. So this is our answer, depending on which format you want it in. Now note, as a side note, this means that this weighted coin is not very good, because if it was not weighted, if it was a fair coin, then we would have the probability of tails for the first toss would be 1/2 because it was a fair coin, times the probability of heads for the second toss, which is again 1/2 because it's a fair coin, which would equal 1/4 or 0.25. So this is not very far removed from that. So it sounds like this coin is not super effective at being a weighted coin. So Before I go, I just want to remind you all that if you are looking for any additional tutoring or academic support at ASU, you can go to the Tutoring Center's website, tutoring.asu.edu, to find all of our resources. Additionally, if you're looking for tutoring services for your specific course, you can use our tutor search tool, which you can find on our main website here or by going directly to the tool at this full link. So thanks so much and have a great rest of your day.